This call is now being recorded.
Okay, good evening. More, in the previous class, we discussed about the context-free grammars and context-free languages. As we discussed earlier, the context-free grammar is a four-tuple. It is a VTPS, where V is a set of non-terminals and T is a terminal symbols, and P is the productions and S is the starting symbol. S is the starting symbol in the given productions. Okay, here it is an example for a context-free grammar. In this grammar, we have the starting symbol as yes, starting symbol yes, and we have these three productions. And coming to non-terminals, we have only one capital symbol. It is also yes, and coming to terminal symbols, it is small symbols. We have only AB. These four comes under the context-free grammar. These four comes under the context-free grammar. Coming to right linear and left linear grammar, if the production is in the form of V tends to T star V. Here V is a non-terminal symbol. It is a capital symbol. If a production is in the form of capital symbol tends to any possibility of small symbol along with ending with a capital symbol, like B. So this type of production is nothing but linear grammars. Linear grammars. Okay. Next, here A tends to XB is a right linear grammar because here we have a rightmost symbol as capital B. It is a non-terminal symbol. Here A tends to XYZB. It is also a right linear grammar because it contains capital B as a rightmost symbol. Before we have three terminal symbols. Here these two are also examples of right linear grammar. Coming to construction of finite automata with the right linear grammar, construction of finite automata with right linear grammar is S tends to epsilon. It is nothing but the production S tends to epsilon is nothing but it is where S is a final state. Here S is the initial state also. So the initial state is represented by the arrow mark, and the final state is represented by double circle. Arrow mark and double circle. Okay, here I will draw here. So yes, we have ABC as a capital symbols. ABC is a capital symbol. So it is the starting symbol and final symbol. The first production is S tends to 0B. S tends to 0B. To the state yes, if I give input 0, then it goes to state B. For the state yes, if I give input 0, it goes to state B. In the same manner, for the state S, if I give input 0, it goes to capital A. It goes to capital A. If it is state A, if I give input 0, then it goes to C state. It is C state. Then if I give input 1 to A, then it is go to S. So it is 1. Then it is for B, if I give input 0, it goes to S. For B, if I give 1, it goes to C. So here they missed some productions. So it is the diagram for the given right linear grammar finite automata. In the same manner, a grammar is said to be left linear grammar if the productions are in the form of non-terminal tends to non-terminal into terminal whole star or non-terminal tends to only terminal star. If the productions are in these two forms, then the grammar is said to be left linear grammar. Okay. Okay. Next. The first, now we'll discuss about some problems in the context free grammar and some problems in ambiguity, and how we will recognize whether the grammar is ambiguity or not. Okay. Here the grammar S tends to ASA, BSB and epsilon or epsilon. It is also called epsilon. It is also called epsilon. Now we will check the language possible by the given alphabets, given productions. First S tends to epsilon and S tends to ASA. So that is A first string. S tends to BSB, that is equal to BB. If I place epsilon in place of S, if I place epsilon in the place of S, so it is possible. Next, here another more possibility is S tends to ASA, S tends to ASA, and again this S is replaced by ASA or BSB. So I will replace BSB, so it is A. And again S is replaced by epsilon, the string is AB, BA. So, in the same manner, there is a possibility of BA, AB, 4 A's and 4 B's also. So, here the language L is equal to epsilon, AA, BB, AA, BAAB, ABBA, ABBA. So, the language is nothing but it is divided into two parts, W and W power R. It is also WBA, W power R AB. Here WAB, BA is nothing but W power R. So it is also W power R. So here W power R is the language, and the productions are S tends to ASA, S tends to BSB, S tends to epsilon. Okay. Coming to context-free grammars, the context-free grammars are accepted by pushdown automata, and pushdown automata accept the language which contains only one condition. Here we have one condition. We need to push the string W, and we need to pop the reverse of the string W power R. Okay, it is one example. We will go with next one. Okay, coming to derivation. Actually, derivation in mathematical derivation is problem solving step by step to achieve the answer. Here is also a derivation. It is an ordered tree which the nodes are labeled with the left sides of productions, and in which children of the node represent the corresponding right sides. Okay. Okay, I will draw here. Here for the grammar, this is called a derivation tree. So S tends to AA, and A is replaced by A small capital B, and B is replaced by B capital B, and again B is replaced by small a. So this form S tends to AA, again AAB, and AAB capital B, and AABA. This form is nothing but a sentimental form. Sentimental form. This is also one more important bit for you people. Sentimental form. Next, here we need to derive AC, BA, BC by using this grammar. We will check now. S tends to A, A, B, and A tends to I need to replace only B, 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 A. So capital B, small a, and again I need to replace this B with small b, capital B, small b, capital B, and finally we need C, right? So it is replaced by C. So it is, so the string is AC, BA, BC. So it is the parse tree for the given grammar. It is the sentimental form for the given grammar. It is a derivation for the given grammar also. Okay. Here it is the step-by-step explanation for the derivation of the string AC, BA, BC. AC, BA, BC. Okay. Here, for this grammar, we will construct parse tree for the string ID plus ID into ID. Okay. ID plus ID into ID. One possibility is E plus E. So this is replaced by ID. This is replaced by E into E, ID. Okay. And one more possibility is, if I take the second production, E into E, now this can be replaced by E plus E. So ID, ID, ID. Here for the string, we have two derivation trees, number one and number two. A grammar contains two derivation trees for the same string. Then the grammar is said to be ambiguous grammar, right? Here are the two derivation trees for the string ID plus ID into ID, ID plus ID into ID. Okay, these type of grammars are said to be ambiguous grammars. Okay, here the question is, obtain the language generated by the given productions. So the first string, here the first string L is equal to the starting, it is A. Next string S tends to double S, A, it is double A. Here, if I replace this with again double S, I have triple A. The same can be done here, this side also. It is also double A, so it is 4 A's. This can be repeated for n number of times. So the language is equal to A power n, where n greater than or equal to 1. So here is the language L is equal to A power N, where N greater than or equal to 1. Okay. We'll go with next topic. Okay. Here we already know about the ambiguity, and ambiguous grammar. An ambiguous grammar is nothing but if there is a possibility of drawing two or more parse trees for the given string by using the grammar, then the grammar is said to be ambiguous grammar. Here is one of the possibility of ambiguous grammar for the string ABAB. Okay. Here, show that the grammar of S tends to S bar S or S tends to A is ambiguous. Okay, we'll show here now. So first is first S tends to S slash S. Now I will replace this S with again S slash S. Again this is replaced by small a. It is small a. It is small a. So here the string is A slash A. Here also S tends to S slash S. I'll replace this set with small a and this with S, sorry, A, S, S slash A. It is small a. It is also small a. It is also the diagram for A slash A slash A. So both the strings are equal. Both the strings are equal. But that we have two different derivation trees for the given grammar and the string are same, then the grammar is said to be ambiguous grammar. Okay. Okay, next we'll go with simplification of grammar. Okay, simplification of context-free grammar comes under three parts. Again, it is elimination of useless symbol and elimination of unit productions and elimination of null productions. Okay, a grammar is more workable if it is simplified. Simplified means by eliminating all these useless symbols and unit productions and epsilon productions also. Okay. So here simplification of context-free grammar, we eliminate the symbols and productions in G which is not useful in the derivation. Okay, the first example is here S tends to ASB or epsilon or A, and A tends to small a or capital A. Here there is no ending for capital A. In this production there is no ending. For example, if it contains slash small a or small epsilon, then it is a valid grammar. So we don't have symbols like this. So the productions with capital A is not useful. It is not terminated in the derivations also. In the not terminated in the derivations also. So the grammar is S tends to A S B or epsilon only. Okay. The production S tends to A does not play any role because A cannot be transformed into a terminal string. A can occur in a string derived from S. This can be never lead to a sententional form. Hence, the production rule can be removed, which does not affect the language. So, we discussed this earlier, right? Right? So, if any production or any non-terminal symbol does not have a terminal, does not have ending, then it is to be removed from the given productions. Then it is said to be elimination of useless productions. Okay, okay. Here also, S tends to capital A. S tends to capital A. A tends to AA. Or A tends to lambda. So we don't have the production for capital B. So here B is said to be useless. Hence the production B tends to be A is also useless, and we need to eliminate the production B tends to be A. So there is no possibility of accessing capital B production in the given grammar. So B can be eliminated. Okay. Okay. Empty production removal or elimination of useless symbol. It is also said to be elimination of epsilon productions. Epsilon productions. A tends to epsilon. A tends to epsilon is said to be epsilon productions. We need to remove this. Okay. We'll see an example. Here we will eliminate epsilon production now. Okay. S tends to A and A tends to AA or epsilon. So we need to eliminate this epsilon by S tends to A and A tends to small a, capital A or small a. Because place epsilon here, we get only small a. Answer is small a. Okay. Next, elimination of unit production. Unit production is nothing but capital symbol tends to capital symbol only. So, a production is said to be in production. It is the form of A tends to B, where A comma B is belongs to at a non-terminal set. Okay. Okay, now we need to eliminate the useless symbols and productions. So we'll see. S tends to AB. S tends to AB. And A tends to small a. B tends to small b. One possibility. So these three are useful. Okay. Next, S tends to AB. We have only one possibility for A, and one more possibility for B is C. And there is no production for C. So it is not useful. And this is also not useful as we don't have any capital E in the right side of the production. Okay. The answer is S tends to A tends to A, B tends to B. So it is the answer, and these two productions are eliminated from the grammar. Okay. Next. Here S tends to small a capital S and S tends to capital A tends to small a. So this production is useful. Okay, if S tends to capital C tends to ACB. So again, there is no ending for C right here. There is no terminal symbol for C. So the productions which contains capital C is useless. So now, and there is no right side production for capital B also. So S tends to AS or capital A tends to small a, capital B tends to double A. Now there is no B production in this, right? So these two only the grammar after eliminating useless symbol. Okay. So it is only the answer. Here, here the elimination of epsilon productions, we have a epsilons in capital B and capital C. So S tends to A, B, A, C. First thing, if I place epsilon, actually B tends to epsilon and C tends to epsilon. So A tends to is also epsilon. So if I place capital A as epsilon, so it is only BAC. If I place capital C as epsilon, it is ABA. If I place capital B as epsilon, it is AAC. If I place capital B and capital C both are epsilons, it is AA. If I place A and C are epsilons, it is BA. If I place uh, it is capital A, it is capital A. So if I place AB or epsilon, the output is small a capital C. And if I place ABC or epsilon, then the answer is small a. So it is that. Here also A tends to BC. So BC I wrote here. And if I place C as epsilon, B is answer. If I place B as epsilon, I place C here. In the same manner, small b is also there, and C tends to capital D, and D tends to small d. Okay, this is nothing but elimination of epsilon productions in the given grammar. Now we need to eliminate the unit productions. Okay, S tends to AB is not as unit production because we have two symbols. A tends to small a is not a unit production. B tends to capital C is a unit production, so we need to leave here. So B tends to small b, and C tends to D is also unit production. D tends to E is also in production. E tends to A. E tends to A is not in production. Here we need to replace this E with small a, this D with small a, this C with small a. Okay, this is the answer. S tends to AB. S tends to AB. A tends to A, B tends to B, B tends to A, C tends to A, B tends to A. Okay. Okay, next we'll go with next example. So eliminate the unit productions here. So here we have the grammar S tends to AB, S tends to AB, A tends to small a, B tends to capital C is in production, and C tends to D is also unit production, and D tends to small b. And in place of capital B, we place small b. In place of capital C, we place small b. So this is the grammar. The final grammar is here. S tends to A, B, A production, B production. There is no need of this C and D production. So it is also eliminated. So S tends to A tends to small a, B tends to small b. Okay, in the same manner, we'll eliminate the unit productions also. Okay. Here we need to eliminate the useless symbols. So S tends to AB. So A can be replaced by small b. So there is no production for B. So the productions which contain the capital C, capital B, so these are useless symbols. S tends to AB is useless. So now the grammar is S tends to small a and A tends to small b. And if I use S tends to small a, there is no capital symbol right side here. So A is also useless. So the final grammar is S tends to small a only. S tends to small a only. Okay. Okay. The simplification of context-free grammar comes under three parts: the elimination of useless symbols, and the elimination of unit productions, and the elimination of epsilon symbols also. Okay, these three comes under the simplification of context-free grammar. If we don't simplify the context-free grammar, then the derivation and parse trees are consuming very time to produce parse trees and uh, derivations. Okay. So eliminate useless productions from the grammar. So S tends to small a is accepted because it is a terminal symbol. S tends to capital A is also okay, whereas we have lambda. S tends to B tends to A, so it is also accepted. S tends to C tends to C. There is no ending for C, so production with C is eliminated and D is also eliminated. The grammar is S tends to A, B, A tends to AB or epsilon, A tends to A is only useful grammar. Okay, thank you.